Hello everyone, today we're going to be graphing quadratics from Vertex Form. Okay, so before we start graphing these things, let's talk about some parts of a parabola. So the one important part is a vertex. So we can see the vertex is right here, and the vertex for the parabola is the turning point of the parabola and is also the highest or the lowest that we are going to see. So it's important for you to know that your vertex is going to be right here. Another important part is the axis of symmetry, okay? So the axis of symmetry for the parabola is the vertical line through the vertex. So we can see it's a line right here, and it's always going to be symmetrical on each side. So we can see that these points are the same distance from that axis of symmetry. Also, these are the same distance from that axis of symmetry. Okay, so that's a couple of important parts of a parabola. So today we are going to be graphing quadratic functions that are written in vertex form. And you can see vertex form right here. Okay, so this is vertex form. Whenever we have these parentheses and we have a number here and a number here, that is vertex form. So important parts of this vertex form is the H and the K, and that's going to tell us where our vertex is. So the X value of our vertex is going to be whatever H is. The Y value of our vertex is going to be whatever K is. So that is our vertex. Okay. And then our axis of symmetry will just be X is equal to H. Whatever the X value of our vertex is, that's where the axis of symmetry is going to be. Okay, so we're going to practice identifying our vertex and axis of symmetry here. So for number one, our vertex, the X value is going to come from inside the parentheses. It's going to be the opposite of what we see there. So -3 is going to become a +3. Our Y value is going to be 6. Okay, and then the axis of symmetry will be, I'm going to call it AOS, is X is equal to 3. Okay, the next one, our vertex, since there's nothing inside of the parentheses, it's just, there are no parentheses, our X value is actually going to be 0. Our Y value is -1. And then our axis of symmetry will be X is equal to 0. Okay. The next one, our vertex, since I have a +5 on the inside, it's going to be -5. And there's nothing after the parentheses, so our Y value is actually 0. And then our axis of symmetry here would be X is equal to -5. And then this last one, our vertex is going to be +7. Y value is -2. And then axis of symmetry will just be X is equal to 7. Okay? So make sure you're able to identify what the vertex is and what the axis of symmetry is if you're given an equation in vertex form. Okay, so today what we're going to be doing is we're going to be taking vertex form and we're going to be graphing these quadratic functions. So our first step is we're going to find the vertex. Okay, so we should be able to identify that easily. Next thing, find the axis of symmetry. And then we're going to make a table, and we're going to choose 2 X values on each side of the vertex. And then we're going to plot and connect our points and draw the axis of symmetry. So let's look at an example of that. So first thing, let's find the vertex. So vertex is going to come from here and here. So our vertex here would be -2, -3. Okay. Axis of symmetry is just X is equal to negative 2. So let's go ahead and plot that. Negative 2, negative 3 is going to be right here. And then our axis of symmetry is going to be a vertical line that goes through that vertex. So you can see it there. So on our table, I'm going to put the vertex in the middle of our table. And then we're going to choose two numbers on each side. So let's do negative 3, negative 4, and then negative 1 and 0. I'm just choosing the numbers that are around the vertex. And we're going to substitute them into this function. So if I put negative 4 right here, negative 4 plus 2 is negative 2. Negative 2 squared is 4. 4 minus 3 is going to be positive 1. If I put negative 3 in, negative 3 plus 2 is 1. Negative 1. Negative 1 squared is 1. 1 minus 3, that's going to be negative 2. And then if I do the same thing with negative 1, negative 1 plus 2 is 1. 1 squared is 1. 1 minus 3, that's also negative 2. And then the last one, 0. 0 plus 2 is 2. 2 squared is 4. 4 minus 3 is 1. So we're going to have a 1 there. Notice that these numbers on opposite sides of the vertex, the y values are the same. Also, these are the same. Our table is always going to be symmetrical around the vertex. Okay, so those numbers should match. So now we're going to plot those. So I've got negative 3, negative 2, negative 4, 1, and then negative 1, negative 2, and 0, 1. And that will give us this parabola. So that's what our function should look like. Okay, so here's another example. So first thing, we're going to find the vertex. So our vertex is going to come from here and here, and our vertex of this thing is going to be 3, 1. And then our axis of symmetry will be x is equal to 3, whatever the x value of your vertex is. All right, so 3, 1 is going to be right here. Okay, our axis of symmetry is just a vertical line that goes through that point. Okay, so on our table, put the vertex in the middle of the table, and then I'm going to pick two numbers on each side. So that would be 1, 2, and then 4, and 5. All right, so if I substitute 1 into this function, 1 minus 3 is going to be negative 2. Negative 2 squared is going to be 4. Negative 1/2 of 4 is going to be negative 2. And negative 2 plus 1 is going to be negative 1. So we're going to put a negative 1 right there. All right. Next one, we're going to sub 2 in. So 2 minus 3 is negative 1. Negative 1 squared is 1. Negative 1/2 times 1 is negative 1/2. Negative 1/2 plus 1 is positive 1/2, or I could write this as 0.5. Okay, so now I should be able to sub 4 in and also get 0.5. Let's double check. 4 minus 3 is 1. 1 squared is also 1. Negative 1/2 times 1 is negative 1/2. Negative 1/2 plus 1, that is going to be 1/2. And then when I sub 5 in, it should also give me negative 1. But let's see. 5 minus 3 is 2. 2 squared is 4. 4 times this is going to be negative 2. Negative 2 plus 1 is negative 1. And now we just plot those points. So 1, negative 1. All right. 2, positive 0.5, 4, positive 0.5, and 5, negative 1. So that gives us this parabola here. So that's what that one's going to look like. And notice that this one is facing down, and that's because we have a negative that is making it reflect over the x-axis. And it also is wider, and that's because it is being shrunk vertically. Okay, so there is our function. All right, here's one more. So again, find the vertex. Our vertex is going to come from right here and here. So the x value is the opposite, so that makes it -1. Our y value is -4. Axis of symmetry is x is equal to -1. So I have this point and the axis of symmetry going through that point. Okay, so we're going to put -1, -4 on our table, and then other x values we could use -3, -2, 0, and 1, and now we're going to sub those in. So -3 plus 1 is -2, -2 squared is 4, 4 times 2 is 8, 8 minus 4 is going to be 4. Okay, now we sub -2 in, so -2 plus 1 is -1, -1 squared is 1, 1 times 2 is 2, 2 minus 4, that's going to be -2. And then when we sub 0 in, that should also be -2, but let's check. 0 plus 1 is 1, 1 squared is 1, 2 times 1 is 2, 2 minus 4 is -2. And then 1 should also give me 4, but let's double check as well. 1 plus 1 is 2, 2 squared is 4, 2 times 4 is 8, 8 minus 4 is 4. And then plot those points. So -3, +4, -2, -2, 0, -2 would go here, and then 1, 4 is going to go here. So our function is going to look like that. Okay, so we see that this one is narrower, and what's causing that to happen is that it's being stretched by this 2 here. Okay, and that's it. So please go check out the assignment on Canvas. What you should be able to do today is identify the vertex, identify the axis of symmetry, and you should be able to create this table and this graph, okay? Please let me know if you have any questions. Have a great day.